I woke up last night and I had a question stuck in my mind. And the question was, how many plugins are enough? And I think I found the answer. Billions and billions and billions and billions. This new plugin is called Network, and basically it creates line segments between points. So let's begin by creating something very simple. I'm going to create a sphere, I'm going to set my Gauss shading lines and go to icosahedron, which is pretty much the standard way we use to start my tutorials. Now, the network has an input field which says objects. Just drag your object here. It's not going to do anything yet. Let me turn off my sphere. And the reason is that we have a maximum distance and a maximum number of connections. I'm going to show you all the details of all the parameters in a second. Now, because these points between each other are more than 10 centimeters, then no connections are generated. So it needs to be large enough to encompass the points. And you can see now, as the number grows, we get more and more connections. So let's leave it at 38. So we only get connections from points which have a distance of 38 or less between each other. And here we're telling it to have a maximum number of connections to 6. If I set this to 2, then it's going to create 2 connections for each point. We won't see more than 2 connections. You can see this point connects to 2, this point connects to 2, and so forth. Now, the scrambler scrambles the indices of the points, because otherwise we would have a more, let's say, uniform connection. You can use it if you want to create more uniform shapes, but if you want this to be totally random, then turn on the scrambler and play around with the seed to create different types of randomizations. Now, these are the simple things. We can also add fields and exclude points from the network plugin. So we have a lot of control here by using fields as masks. Either a point is connected or it's not. It's totally ignored. So let me go and remove the linear field from here. Now that I've shown you the fundamentals, let me show you what you can do with it, and then I'm going to provide you with a bunch of examples which we're going to go through very, very quickly so I don't waste your time, and also because a lot of you watch the beginning of the tutorial or just don't know the plugin, and my analytics is not as good as I want them to. So if you don't watch the whole video and you don't give a thumbs up and you don't subscribe, you are a rotten egg. So let's create a new scene, and let's go and create a matrix object. Now, we know from the matrix parameters that each matrix is distanced at 10.5 centimeters from each other, and the network plugin can read matrices. So let's just make this invisible and take the matrix and drag it in the object link of the matrix, and let's set this to be a bit more than 10.5, so I'll make it 11, and you will see that it's going to generate little squares. Now, that's because I have a maximum number of connections to 6, which means that everything gets connected within the range of 11 centimeters because all the other points are quite far away. Now, first of all, let me show you what happens if you set the maximum distance to something, let's say 22. Now we're going to have more connections, diagonal connections and so forth, because the points between themselves, this point and this point, for example, let's go close to this one and this one, are within the range of 22 centimeters. So let me set this back to 12, and now I'm going to set my maximum connections to 3 instead of 6, and suddenly we're starting to get interesting shapes like this. This looks like something, but it's not a grid. Now, the good thing about this is because the network plugin generates a spline, we can go and add an extrude generator, and if I set it to the y-axis and make this a bit shorter, we can create very interesting shapes here. I'm going to turn on my Gauss shading line so you can see the shape in all its glory. Fantastic. Now, even better, if I go to the network plugin, not the matrix, if I say maximum connections to 2, now we're getting an actual little maze which you can play. You can go in here and say, oh, I'm going to find out how to, go all the way. No, you can't do that, so forget about it. You can go this way. All right, I'm digressing again. So let's see what else we can do by showing you a few examples and certain tricks I use. So let's begin with the tricks. In a new scene, what I'm going to generate here is a sphere in icosahedron mode. I'm going to set this to, let's say, 22. Now I'm going to create another sphere, a copy of that sphere, which is going to be slightly smaller. Now let's go to my top view so we can see what's going on. I'm going to make a third one, which is slightly smaller here. And I'm going to set this to be, let's say, 16 points. And let's go to this one and set it to 9 points. Now be very careful with the point counts because the number of calculations increases quite a bit. At the end of the video I'm going to show you why this happens because using a brute force algorithm that compares all the points all the time to find the points that lie within the maximum range and all that is an unfortunate effect of these kind of algorithms. And although there are ways to make it faster, it's much harder to implement. So anyway, this is what we have. Now let's go to our 3D view and let's create a null and let's hide all these and let's hide them. Good. And let's go and bring up the network plugin, pull it down, and let's go and add these spheres here one by one. Excellent. And let's go and increase the max distance. And let's go over here. And you can see now that it's connecting not only the points of each object with itself, but between all the objects. What happens is that anything in this list is considered a valid point, and the plugin does not distinguish between points of the same object or of other objects. I can even go for good measure here and add a matrix in the mix and go here, add it right there, and let's turn off the matrix, and you can see we already have a slowdown and we get all these interesting connections. Now another thing you can do is add particles. And in order to add particles, and let's go to a new scene and let's create another network. Here's the catch. Let's go to the particles emitter and emit some particles, and let's go to the network and drag this and put it in here and see what happens. Let's increase this to, let's say, 240. And you can see that nothing happens in this particular case. That's because the particles are not read directly. But there's a trick we can do to make the network read them, and that is by using a matrix object in object mode. In the object we drag our emitter. Excellent. And now I can make this invisible, and now in the network I can use the matrix because it works. So you can create very interesting effects like this, and if I start making my max distance smaller, we will be getting an interesting effect of these lines moving. Now I can always go and add some an angle so these sort of open up as well, so their distance changes. So now we're getting something which is a bit more fancy, and let's go and increase this. There you go. This alone is worth, I would say, $1 million, but I'm giving it for free anyhow. So let's now take a look at some of the examples I've prepared for you. You can download them all in the link in the description text below. I have no idea how many times I've said the same phrase again and again. The link is in the description text below. The link is in the description text below. This very simple example here, I think, is worth its money. The plugin is worth the $0 it costs, and it's very easy to set up. It's just a matrix, a network, and a random field in the network field list. Now, before I set this up from scratch, there's one little thing that may or may not happen. If you have a field in the field list of the network and you turn it off and then on, there is a small chance that it won't update. Now, there are two things that happen here. Number one, if you turn off the field, nothing will be generated because in the network this field, now it's not active and it doesn't know which point. Anyhow, it's a small technical thing which we haven't been able to solve. And see, when there's a mistake, I use plural, that we couldn't solve it, but I take all credit for this nonetheless. Anyway, and make sure that if you don't want the field anymore, you remove it altogether, so you can see everything. Don't just deactivate it. Now, if for any reason you want to turn it on and it doesn't reappear, just go to the network and turn it off and on again, and then it will work. So that's the short version of it. Turn it off and on and it will work, and remove your fields instead of deactivating them. Anyway, so let's set this up. It's very, very simple. Let's create a new scene. Let's create a matrix, and let's set this to, let's say, 10 by 10 by 10. And we know that these are 10.5 apart. Let's make this invisible, and let's go and add our fantastic network plugin. So I'm going to drag the matrix in the object of the object tab, and it's going to do connections if this is more than 10.5. So I'm going to set it to 11, and you can see now that we get this fantastic grid of lines. I think this is the easiest way to do this anyhow. Now I'm going to set my max connections to 3, and look at this, and then I can go and add a field with a random field in it, and just set this to animate, and let's go and turn off the random field because these purple lines irritate me. And there you go. If you want to make it even fancier, just go to the network, go to the basic tab, go to automatic color, and make it blue, because all these things are usually blue or green or red or any color for that matter. But there you go. We have this nice little animated cage, and this is very fooey-y. So let's check out another example. In this example here, if I take my null and I rotate it, I create these very interesting patterns that fall on a sphere. And what I've done here is the following thing. Let's just turn off all these, and you can see that the main object is an icosahedron sphere, and that's all nice and dandy. Now what I'm doing is I'm using the matrix in object mode, and I'm distributing on the vertices. So I'm creating, you can see, all these nice little matrices. Now let's go and turn on the network, and you can see that we get these intermediate little points here. So although my distribution is vertex, and the reason is that if I select the sphere and go to points mode, I've actually subdivided these edges without creating the intermediate edges over here. And what I'm achieving with this is that I'm getting more points but fewer edges, and that's just what I wanted to do. So don't be surprised as to why the matrix is generating these intermediate points. Let's turn on the network, and you can see that these nice little points now are allowing the network to create this webby look, because I've set the maximum distance and the max connections and all that, and you can play around with this. The slight difference in this scene is that instead of putting my spherical field in the network field list, I'm actually putting it in the matrix through a plane effector, and you can see here, and the parameter I'm using is visibility. So the visibility of the matrices is respected when using the network plugin. On to another brilliant example again. This one here is an interesting one where it creates this very, very creepy crawly construct over here, and the concept is very simple. So I've generated a number of spheres inside each other because I just want to have some sort of volume, so to speak. I want some points that can connect inwards as well. Fantastic. And then what I'm doing is I'm using the network with all these spheres in here. Now let me turn off not the network but the volume builder and volume mesher, and you can see in the field I have the spherical field here, which I'm going to delete now because you saw what it does. And this is basically the structure I'm creating, and I'm putting it in a volume builder, volume mesher, and a smoothing to make it nice and stringy. And look at this. This is a very interesting indeed. Now let's go to a similar example, and I'll show you how to create a really good looking trabecular structure. So here it is. You can see it's very interesting, and it's interesting because I'm using a low number of connections, so it creates a very, very interesting web of connections in here. And again, the idea is just like the previous one: 3 spheres, I have a field, the linear field, which I'm going to get rid of so we can see the whole thing. So we can go inside and look at it and see what's going on in this object. But you can see that we're getting these very, very non-uniform, very interesting shapes. And that's because this is the web of lines that the network plugin is generating, again with 3 nested spheres. And then I'm just putting it again, volume builder a bit thicker this time, volume mesher, and then a delta mesh instead of a smoothing deformer, just so that I can diversify my methodologies. The final example that's going to blow you out of the water is this one over here. It's a nice little web that's growing. Fantastic. Let me show you how I did this. First of all, this requires a very, 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 very complex espresso setup for the thinking particles. If you double click, it's just one node. Just add p matter waves. Of course, I'm being sarcastic. And in the p matter waves, just add the sphere object, make sure it's an editable object, and I think everything else is pretty much the default value. And this will start making particles flying away. Now, what else have I done? Well, I'm actually using the matrix object to read the all group. Now, by the way, if you go to simulate thinking particles and TP settings, you can see all the available groups. The all group is the default group. And if you want to make a matrix object generate matrices on thinking particles, just grab this group here and put it over here. Now, the next thing I'm doing is I'm going to a tracer object, and I'm tracing the actual particles by tracing this link, the same all group I did earlier. Fantastic. Now, in a Spline, I'm taking this tracer. I've set the Spline to spline mode, and you can see that the source spline is the tracer. Now, the reason I'm doing this is that when you trace particles, or any motion for that matter, because you can see it's set to trace paths, and it traces the TP subgroups and whatnot. Anyhow, it's tracing the particles. So every frame, if I right click here and say current state to object, what you will see is that for every frame we get a point. And this can get really expensive in terms of how many points are generated, and it will get really, really, really slow. So I'm using the Spline in spline mode, using the tracer, but I've reduced the count to 5. So if I take this Spline and say current state to object and select it and go to points mode, what you will see, if I make it visible, that is, that we have 5 points per line. So this reduces the amount of points quite significantly. And then I'm taking this Spline and I'm dragging it here alongside with these spheres, because I want these to have other places to touch upon, not only the splines, just to create a bit of a more random shape. And this is a result. Again, you feel free to go and dissect these files and see how I did them. They're fairly straightforward. And now for something totally different. I want to explain why, if you have larger point counts, it becomes extremely, extremely slow. So this is for the geeks, but please watch it because I'm sure you're going to learn something. Now, if I go to Tools and get my Doodle Paint, we have 6 points here. So when we say we want the unique connections of each point with every other point, then this is what happens. This point will connect to this, 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 and this. So if we have 6 points, the first one will connect to 5 points because it doesn't connect to itself. So here we have 5. Now the next one, because it already has a connection with the first one, will connect to 1 less. So everything except the first one. So that will be 4. This one will be 3. There we go, 3. This one will be 2. And this one will be 1. Excellent. So 5 and 4 is 9, and 6 is 15. And basically, this is the sum of all numbers from 1 to 5, which is basically, if you write it in the mathematical notation, it's from something to something and something to something to something to something. And I'm going to show you what that means. Because the internet is better at explaining some very specific things than I am, this is the sum of all numbers from 1 to 6. There you go. This is how it's done. And you can see for 6 points, it needs to do 15 loops to find out all these connections. If we make it 60 points, it's 1,770. You can see that they're much more connections as the points increase. So you can increase this by just 1 point, and this will increase by 60 or something like that. Actually, it's 60. So if I go 62, then it's plus 61. If I go 63, then it's plus 62. So when we get to point counts like 2,000 points, it actually has to perform the loop to find all the other points and record their position and create the internal database and all that 2 million times. So that's why, although with 2,000 points that doesn't seem to be such a huge number of points, yet the algorithm, the way it's written, has to do 2 million calculations, and that's not a simple calculation. Now, there are methods to optimize these sorts of things using quad trees and stuff like that, but that's much harder to implement, and if you want something like that, you will have to pay for it. Starting bids at $1,999,000. And there you have it. Another great plugin from the likes of me. So don't forget, subscribe, like, ring the bell, the notifications, follow me on Twitter, and all the information is available, and see you in the other one. Or shall I say, see you next time? Maybe I should say toodaloo.